Hey everybody, so we're going to be talking about graphs of polynomials, part 2. In part 1, I showed you what the parent function is and what each number in the equation means and what it represents. So in this, we're going to be actually using the graph, and we're going to be making the equation out of that. So the first parabola we're going to have is going to be this one. The width is not the scale, so you can't really judge that as of right now. So our vertex, you have to look at how many points intersect the x-axis, and there's only one. It's going to be this one. It's going to be -1 and 0. So your vertex is going to be -1 and 0. So with that, we'll start the equation. As I stated in my before video, the parent function is y equals x to the second power. So what minus 1 equals 0? And so it would be 1. So we're going to go x, and it would be x plus 1, because 1 minus 1 equals 0 squared. So how we get this inside and not this is because we have x, and now that we have plus 1. So when you're going on the x-axis, you're always going to do the opposite of what the number is. So since it's -1, we're going to put 1. Since both of them are squared, because whatever's inside of x is going to be squared. So now the 1 is going to be inside the x. So x plus 1 squared. So you're going to square everything. Now we can actually simplify that using the box method or FOIL. So x times x would be x squared. 1 times x would just be x. X times 1 would just be x. And 1 times 1 would be x. So you write the equation as y equals x squared plus combine like terms. So x plus x is going to be 2x plus 1. So this should be your equation to this graph right here. So this is going to be our next one. So we have 2 points. So basically the parent function is going to be this. So what are we doing? So the parent function again is going to be y equals x squared. So now there's going to be a shift on the y-axis, which is going down. It's actually going to go down 1. So since we're not dealing with I totally screwed that up. Since we're not working with the x-axis, it's not going to be included with that. So we can write y equals x squared. Now we're going to look on what happens to the y. Is it going up 1? Is it going down 1? What's happening? And in this one, it goes from 0 of the y to -1. So -1. Since this is the y-axis, you don't need to change the value because you're not going to be adding it to that. So it's not going to be x plus 1, it's going to be x minus 1. So this would be your equation to that graph. The last problem includes both of them on how to solve them both. I did not draw a perfect graph, but there it is. So it hits the point 1, 1. So that's going to be our vertex. So now we're going to write y equals, remember I'm going to put the parent function again, y equals x squared. That's going to be the parent function. So now we have y equals, is it x moving to the left or to the right? And it's going to be moving to the right, 1. So what plus 1 equals 0? And it's going to be negative 1. So x minus 1 squared, but we have another shift. So not only we're going to go right 1, we're going to go up 1. And remember, on the y-axis, if we go up 1, it's going to be a positive 1 because we don't have to change the value of it. So it's going to be plus 1. Now we can simplify the x minus 1 squared. Again, you can use the FOIL or the box method. So now x times x is going to be x squared. Negative 1 times x is going to be negative x. X times negative 1 is going to be negative x. And negative 1 times negative 1 is going to be 1. So how you rewrite this is going to be y equals x squared. Combine like terms, so negative x plus negative x is going to be negative 2x. And then plus 1. And then don't forget the other plus 1. So now we have another like terms. 1 plus 1 equals 2. So how you rewrite this is going to be y equals x squared minus 2x plus 2. So this will be your final answer. And that concludes it for this one. And see you in part 3. Bye.